Hey everybody, how's it going? So this is the third video in regards to the solid principles, and the principle I'm going to be looking at in this video is referred to as the Liskov Substitution principle. Now this will be a pretty short video just simply because this is a pretty simple idea, and to be honest with you, a lot of people do this right a lot of the time, okay? So basically what the Liskov substitution principle is when you sit there and you write a method that expects some kind of an object, you provide the base class or the minimum class required to execute that method, okay? So the example I have in this document is I'm talking about animals and cats and dogs, right? And down the line I'm talking about the fact that animal is an abstract class, and the cats and dog is inheriting from that abstract class, even though I forgot to include the inheritance part here. So I might just quickly fix this up. That's meant to happen like so. And basically, I'm then coming down and I'm talking about the fact that we don't want to have two methods like this, where underneath we're just calling speak on the two different types here, which is cat and dog, right? And then I say, well, the better outcome is to create just the one method, passing in the base object, and then the subtypes can be replaced with that base object, and you can call the individual speak method on that, right? So that's essentially what we're looking at in terms of this principle, is being able to swap out a base class with a subclass and things still work the way you think it would, okay? So let's see that with a little bit of code from our example that we've been working on. So I've got the code open in front of me here, and as you can see right in front of me right now, we have this report entry class. Now this is a class I've been using to, basically encapsulate the data, but you can see it's a very basic name, report entry. Now what I want to do for this video is I want to create two more classes that inherit from this one and have different properties, and see if the code that we have at the moment will stand up properly to this Liskov substitution principle, okay? So the first thing I'm going to do is I'm going to make this class abstract. And the reason why I'm making it abstract is because I want to implement two classes that can be used, or will have this as the base class. I do not want this class to be instantiated. So automatically what we're going to have inside the in-memory data provider is we're going to get an error because now we can't instantiate this report entry directly. Alright, so the next thing I'm going to do is I'm going to come up and I'm going to create two classes. Right, so first one I'm going to call, let's go simple report entry. Okay, and go new. And I'll create another one quickly as well. So once again, add a new file. And let's, for fun's sake, call this one complex report entry. And go new. Now, coming back to the simple entry, first thing we're going to do is we're going to inherit from that report entry. Alright, so with that done, we get access to both column 1 and column 2. Right, the properties there, and then I'm just going to add another one here quickly, and I'll just call it column 3, so to speak. So let's go string, and we'll call it column 3. Right, and I don't like the fact that this goes on separate lines, but I'll just leave it as it is for now. I'll clean it up a little bit later. I'll just remove this unused using as well. So that's one report entry that I've created. I'll come to the complex one, and just to be a little bit more fancy, I might, for this one, create a more complex object, say, I don't know, try and think of a class at the moment that I can use. Let's create an array, okay? So we'll go prop, and in fact we'll implement an IEnumerable we'll say int, right? And we'll say special numbers or something. It really doesn't matter what it is, to be honest with you, as long as it's a little bit more complicated than the simple one, right? So that's all cool. We've got our two different report entries now. And what have we got here? I've accidentally hit that twice or something. Public, special number. Yep, so that's all good. So now that we have our two entries, right, I'm going to want to set up two providers now because they're two different types of entries. So for this in-memory data provider that we were using to just return the standard report entries, I'm going to call this one now called the simple in-memory data provider. Okay, so I'll come over and rename it over here as well, and rename, and I will call it a simple in-memory data provider. Okay. Now, technically, I still need to implement the public list report entry object here, get data, because we're still using the iData provider, right? But what I'm going to return here is a new class called the simple report entry, right? And that's that class that we created here. So just to quickly jump back to the memory thing, I'm going to make sure that we populate the right entries like so. And in fact, what I might do here is I'll create a variable simple entry equals new simple report entry. And it looks like I got to include this, which I haven't done yet. And for whatever reason, it doesn't seem to want to come up with what it is. So I'll just add the using statement directly. In fact, this is a little strange because the simple report entry should be just coming up because it's in the same folder. Strange. I think it's actually working. I think there's just something wrong with the highlighting here. So coming over, I'm going to put column 1. Even the IntelliSense isn't working. Column 2. Equals whatever. And column 3. So we'll just copy what's down here. So column 1 value, column 2 value, and just hang on, I need to rename that. And we'll say same thing. Here we'll just put column 3 value. And then we will just add this entry directly to the entries array. Alright, so we've got something very similar to what we had in the previous video, except now this time we're returning something that's of type report entry, but in our case it happens to be the simple report entry. I'm just going to close this file. I'm new to Visual Studio on Mac, so this is something that's a bit of an exploration. I think it might be just an issue with the IDE. And I'm going to come over to the simple in-memory data provider again, and I'm still getting. I'm gonna compile this quickly just to make sure it's running. I'm not getting an error here. And oh yeah, that's okay. Simple in-memory data provider. It looks like it's going to compile, but we've got 2 errors up here. Let's try and compile it again. And we got another error, which is to return entries. And the reason is because this still needs to be a report entry. Like so. So the list still has to be a report entry here, but we're putting in a simple report entry into that list. Okay, that's the difference there. I just made a slight mistake. So we're saying we have this list of report entries we're going to pass or return. We instantiate that list when we instantiate the provider, and then we're going to create a simple report entry, add it to that list, which is a report entry list, and then we'll return it. So once again, I will give this a build, and we should be fine this time, and we are. So interesting there. Still IntelliSense not really giving me what I need, but that's okay. So that's the modified simple in-memory data provider. Now I'm going to create one for a complex one. So we'll just go add new file, and we'll create a complex in-memory data provider. New. And I'm going to take most of the code that's over here because it's pretty much going to be very similar. So just copy and paste. And I'll rename the constructor. And we'll include the list. So we'll grab that. Whoops. And remove that using statement there. Now, this is still returning a simple report entry. I'm going to change this to a complex report entry. And so, that's interesting. Complex report entry. I mustn't have set the base, and I hadn't. So, one thing I forgot to do here is just make sure we're inheriting from report entry. That's the cool thing about inheritance and using it in this manner. It's easy to pick up mistakes that you make. So now, yeah, so column 3 doesn't exist. That's okay. So what did I do? What other thing do I have? What did I call it? What was the other property I called? Special numbers. So I go special numbers equals new. Let's say list of int. All right, and we'll just go 1, 2, 3, 4, 5. That'll do. All right, we're just going to grab that, dump that in. I'm going to rename this just to complex entry just to be complete. All right, and we've got pretty much the same provider that we had before, except this one is not implementing the iData provider yet, so we need to do that. All right, so that will enforce this signature here. And now we can actually use both of these different providers to our report generator because they're returning this right here, which is the important part. So what we've done is we're now substituting, in the case of the report entry, we're now substituting a subtype called complex report entry. Now hopefully when I implement this, this should all just run smoothly, okay? Which means that we've abided by the rules of the Liskov substitution principle. So let's go back to the program. And the first example I have here is the simple in-memory data provider. And what I'm also going to do is I'm also going to new up a complex in-memory data provider. Right, and we'll copy these two lines here. And we'll say simple formatted results. So I'm just going to rename some of these things so we know what they are. And this one will be a complex formatted result. And the second one will change its data provider from the simple one to now use the complex one. Now, as you can see, because we're using subtyping, we're not getting any compiler issues because we can put in places they expect a base type, a subtype, okay? That's the beautiful thing of C#. This is built in by default as part of the compiler. So, now let's give this a run and see if we get what we expect, which is the first one will output one entry with a column 1, 2, and 3. The second one will print out an entry with column 1, 2, and then some special numbers. But the only thing we need to change here was where the data came from. The formatter is the same, and the generator code is the same, right? So this makes us pretty flexible. So let's quickly run this and see what we get. So hopefully you can see what's in front of you right now. And the first one that's spat out is the result of the first call, which is, it's got column 3, which has column 3 value, column 1 with column 1 value, column 2 with column 2 value. And then the second one is the more complex one with the special numbers property, which has 1, 2, 3, 4, 5. And then we have the column 1 with column value 1 and column 2 with column value 2, right? So that's cool. It seems to be working as we expect by just substituting one report type with another. So let's just quickly analyze what we've done here. So going back to the main method we have here, we have the same report generator that we've used, right? We have the same report formatter to format both the different reports, right? The only thing that's changed is the provider, right? And what we've changed in these two different providers is not very much either, but what we have changed is very important. So if I come over to the simple in-memory provider and we look at the get data call, when we're returning the list of report entries, we're actually able to substitute this report entry type with a subtype of simple report entry. So that allows us to push in an object that is of a different type here, right? Which is cool because number one, it allows us to serialize an object that isn't necessarily of this type, but is a child of that type. And in cases of other programs, this may have methods on it that are shared between, or that are inherited by this report entry, and basically our methods can call out those methods as well because they understand the report entry. Okay, so that's the other aspect of it. So for example, if I was to come over to the report generator, right, and I just go entries, right, if I grab the first entry here, so we go entries dot first and entry. In fact, I won't use link here. I'll just literally grab the index 0 just to make things easy. And what you will see here is we can get access to column 1 and column 2, but we don't see column 3, and we also don't see the special numbers, right? Because this thing is only dealing with basically a standard entry. It's not dealing with, you know, the complex or the simple entries. But because we can pass those in, and because this formatter is smart enough to read and reflect through that object, it can still produce the columns that are inside that object anyway, okay? And that's the key of the JSON formatter. So now coming over to the complex report entry, complex provider, and same code here. We're still returning a report entry, but what we're doing is we're using a complex report entry here to add to the list and return it. Okay, so we are able to substitute, you know, a report entry with something else, and that is the key to that principle. All right. Now, really not much to this principle, simply because C# does this by default using polymorphism, but it's just important to point this out anyway, okay? So that's it for this video. There's not much to talk about here. In the next video, we're going to look at another topic called interface segregation, and that will probably be with a different example altogether. So I'll see you in the next video.